Hello everybody and welcome back to the Renaissance Builder. Now today we are adding a liquid cooling solution to our graphics card on this computer. Now to the tech tuber world, this is something that's done every day. But me, I've never done this before in my life. So stick around to see how much we botch this one up. Welcome to the Renaissance Builder. Alright, so I feel like I should explain a few things before we get digging into this. For one, why do I have a motherboard box on my desk? Well, anytime you're working on a computer, building a computer, taking components on a computer apart, anything with electronics, honestly, you want to try your best to avoid static discharges. Static discharges, I can't talk right, can be very bad for electronic devices. I do not personally have, because, well, they're expensive, a build mat as of yet. It's on the list, but, you know, someday. So, since I don't have a build mat per se that is designed to, you know, negate the static discharge, then building on top of your motherboard box is actually a pretty decent solution. So that's why that's there. Now the graphics card that we're dealing with today is a 2080 Ti Founders Edition. So it's not one of these fancy overclocked cards, it's just a very solid graphics card to use in this situation. The water block we're going to be using is the Corsair XG7 RGB. Now RGB wasn't exactly the point of this, but supposedly Corsair's water block solution for graphics cards is designed so that everything that would normally be difficult is done for you. All the thermal paste or pads is already applied, and really all you need to do is unbolt the heatsink, the factory heatsink, and bolt this one on. So we're going to put that to the test, which is why I started this video by saying I've never done this before in my life. Because I haven't. So since this is such a new experience for me, I thought it might be useful to my viewers out here who maybe have never done the same thing either. Or done one of these things before ever. My grasp of the English language is, alas, lacking. And I wax poetic. So hopefully you guys are enjoying these videos, but I'll tell you what, most of you guys out there are not subscribed, and it would make a massive difference to the channel and to me personally if you go ahead and hit that subscribe button. I promise it doesn't cost you a thing, but it really helps us out a lot. The whole point of this, aside from getting the graphics card on a liquid loop because of ease of cooling, but the whole point of this, well, the whole point of this channel, right, has become at least morphed into a let's see if we can make everything cold kind of thing. Liquid cool all of the things. Anyhow, the point of this, the reason we're doing this is because graphics cards are unique in that their firmware allows you to overclock or overdrive or get more performance out of the equipment the colder it is. So the hotter the card gets, the less performance you get out of it. Now, a liquid cooling solution is essentially the go-to solution when you really want to make sure that your card will not overheat no matter what you throw at it. So getting into this, the process that we're going to do is I'm going to remove the graphics card from the computer. It's already shut off and isolated. Then we're going to take it apart. Once I have that taken apart, then we're going to take the water block and, you know, disassemble it and put it back together. The accoutrements that go with it, the hoses and the fittings and stuff, I have all that in a separate box. That's kind of besides the point. They're pretty easy. G1 quarter, 3/8 barbed hose fittings, and then the hose that's already there. So that's pretty straightforward. With that being said, I guess let's get into it. Now, removing a graphics card itself is actually a pretty straightforward thing. First, you want to unplug all of the things, starting with the HDMI and monitor plug. So it's either an HDMI or a display port or whatever you got plugged into the back of it. So you start with that. At that point, you want to unplug any extra power supplies that are added onto the back, and that's right here. So we're going to unplug this. Now at this point what you want to do is, there is a bracket at the rear of the case. There's the bracket that holds all of your extra cards together, and there's usually either a screw, one or multiple screws that are fastening that together. I'll add in an overscreen to show you, an image to show you that getting done. Yeah, so we're just going to take those screws out. Now with the bracket in the back of the video card loosened, so the screws are not holding it down, there's one more piece that you need to be aware of that's down inside the motherboard. It's a little finger, and I will try to take a photo shoot of it for you, but there's a little finger in the PCI Express slot that is a latch, essentially, and you have to get that finger and push it down to loosen the latch for the graphics card, and then you can pull it up. So got that finger out, and then we can pull the video card out. Ta-da! See? It's that simple. Alright, now for the rest of the teardown, at this point we have the video card out, and we're going to start tearing it down. This part, I'm going to try giving you guys the best possible angle for your enjoyment. The best angle for your enjoyment. Just because, you guys are the ones that matter. Now, I did not prepare for this. I did not watch any other YouTube channels on how to do this. So I really honestly don't know which part comes off first. I do know that I believe this here middle part is actually held on by glue. So this is non-consequential, and these screws are dressing, actually. They do not go through to the card. So, that being said, I'm pretty sure that this top piece is held on by whatever's behind here. So I think our objective is we need to take this one off first. So I'm actually going to use my handy dandy iFixit kit here to its fullest potential as a parts tray to keep all the screws organized, as well as all the right screwdrivers that we need. Now, I'm going to do the little screws first. And we have to keep in mind when we do this to look out for any screws that are longer or shorter. So now with all the tiny little screws removed, the backing plate, now these screws do not hold the backing plate on, the larger screws. They actually go through and they hold the front side on. So now we can actually pull off the aluminum backing plate, and be careful because underneath there's actually, this is heat transfer tape. So there's a bunch of these little pieces over here, and they're there for a reason. They're there to transfer heat off of some of these individual components and put that heat into the back plate. So those, be careful when you're removing it, and try to make sure they stay in the same position that it was in the first place. Now at this point we can actually take these screws out, because these screws right here actually go through the die, or the GPU die. The chip itself is right here, and these screws right here actually go the whole way through and anchor the heatsink to the chip die itself. So at this point we can take these off. If you look very closely, you can actually tell that the sockets or the nuts that the tiny screws were screwing into are screws themselves. So they are fasteners, and we need to take those off. Now, thanks to my handy dandy iFixit kit, we have several different sizes for sockets that should be good for that. Oh, yep, there we go. It's a number 4, I believe. Yep. All right, so we're going to change up and remove all of these nuts. These ones are a little harder because they're actually anchoring the PCB down, or the heatsink down to the PCB. So you can see, if it focuses it in, you can actually see that little fastener right there. So we got to remove all of these. There's a bunch of them. Always try to be very careful when you're doing this. Driving anything right on top of the PCB, because nothing will kill a computer device faster than slipping and running your driver across the PCB. And that would be a very bad day. Alright, so now all of those are out. It looks like the I/O shield actually has 2 little fingers that run over top, so we're going to have to remove the I/O shield as well. So we're just going to go over here and take the screws out. The screws are right in here, so we're just going to go ahead and take the I/O shield off as well. So there's your I/O shield, got that off, set that to the side. Now at this point, it should come apart. So let's see what happens. Now, before we get to doing this, this is a good opportunity, good stopping place to say, be very careful when you're doing this, because there are a lot of heat pads and everything underneath this, and you don't want to lose those or get all that screwed up. There also should be a plug, I believe, somewhere in here, so we need to keep track of that as well. So I'm just going to take a plastic pry bar here and gently lift up on the PCB. Okay, and while I'm doing that, I'm actually going to look in to make sure I'm not stressing out any plugs. All right, so I got a plug. So I got a plug on this end underneath the PCB that I need to unplug. It doesn't look like that should be too difficult. And the grand reveal. Oh. There it is. Whew. All right, so it looks like we do have a couple thermal pads that came off and need to be reset. Now here's the thing. So here you go. This is where all the money's at. Oh boy. Alright, so what you want to do at this point is make sure that all the thermal pads are off of the actual PCB right here, and that they're all on your heatsink and in the orientation that they need to be. You don't really get a layout. You might be able to find it online, I guess, but you don't really get more of a layout than right now as to where all these pieces go. So if you're going to be putting this back together, all these heat pads need to be in the exact right location. So now we can take the heatsink, which is, you know, this, and we can set that to the side because we don't need it anymore. Now at this point, we're going to go ahead and clean off our PCB. We need to clean off all the thermal paste and the leftover residues to make sure this is clean. Because I believe, at least what I'm told what's supposed to be, is that the new water block comes with all the tape and everything we need already on it. And if that's the case, that will be great. So we'll get this thing cleaned up and get right back at it. All right, so at this point I've actually had the opportunity to get in here and clean this board up a bit. We've removed the thermal paste that was on the die itself. And when I say die, I mean the main computer chip, the GPU, the actual chip itself that does all the work. That has a paste. They call it a TIM, thermal interface material, whatever. Anyhow, we cleaned all that up. It's not very difficult to do. You can use denatured alcohol is the easiest way to do it, and some paper towels that don't leave lint, right? So shop towels are good, those blue paper shop towels. They work great. Either way, it doesn't have to be absolutely perfect. If you're, doing this for the first time, don't worry about every little nook and cranny. Q-tips go a long way if you really do want to get in there and clean it up nicely, for that picture perfect shot. But it's not all that necessary. This isn't a tech channel, right? I am not an authority on computer parts, or I'm not an electronics engineer, so most of this stuff I don't know what it is. But it is still really neat. Okay, take two. All right, so now the first step in reassembly is to prepare the water block. Well, I guess technically the first step would be the cleaning, but we already did that. So the first step in reassembly is to prepare the water block. Now, I went ahead and removed the factory thermal interface material that they gave us because, frankly, I wanted to use my own. Now, we are using Thermal Grizzly's Cryonaut thermal paste in here. So I went ahead and cleaned off that surface, all right? Now, the biggest and most important thing is to figure out what we are going to do with our water inlet and outlet. Now they provide 2 plugs along with the screws that they want us to use. So I'm just going to pull these plugs out. And again, it's G1/4, G meaning gasketed, so you don't really have to be, you don't have to go all Hulk on it or use any Teflon or any other thread sealing apparatus. And then they give you this little key that's supposed to be, I guess, because you don't have a flathead screwdriver or something. So I'm just going to put the screws to the side in our screw bin over here. And you might recognize these from the last video, are G1/4 to 3/8 barbed fittings. So these are the fittings that we're using on the rest of the computer. They work perfectly fine. There's nothing wrong with them. No, they're not the snazziest, but that's not what we're going for right now. This is more about being functional than snazzy. Okay, so the inlet is, this side is the inlet. See? You got to do these things. Now, the way this loop is going to be oriented is we are going to inlet into the graphics card first, and then from the graphics card, we're going to go to the CPU. The reason for this is the graphics card, I actually kind of mentioned this earlier, graphics cards are actually very thermally dependent. A processor can change. It can vary. The temperature can change and it will still maintain a certain performance up to a certain point. But a graphics card will always work better the colder it is. So you want to give your graphics card, for best performance, you want to give your graphics card the fresh, coolest water possible. Okay, so now at this point we're just going to thread our fittings in. And it only has to be hand tight. You don't have to wrench on the bloody things. And our inlet over here. So what I'm actually going to be doing here is we're going to be coming from the pump into the graphics card, from the graphics card to the processor, and then from the processor to the radiator, from the radiator back to the pump. All right, so now we're going to take the graphics card proper, and we need to apply our thermal paste to there. Now, in this case, I might actually use a spludger to smooth this stuff out, because I don't necessarily want to count on, I don't really want to count on the pressure moving it out. And we want to make sure this is thoroughly covered, because another thing I'm going to criticize Corsair for, listen, I don't know if you can hear this. So that scratching sound are machine marks, which means they didn't even bother to polish the fret. They polished everything else that doesn't matter, but they didn't bother to polish the actual heatsink surface, which is retarded. And the reason that's retarded is you'll notice that NVIDIA, their chip is mirror smooth. It is straight up polished. Yes, there's some etching in there, but whatever, they wanted their mark. But it is mirror smooth. The smoother the surface is, the less thermal interface you need. But since they left the machine marks on that surface, it's going to need a lot more thermal interface, which makes the heat exchange even less efficient. So I'm sorry, Corsair, you guys really just left a lot on the table. It's honestly quite disappointing. I may even just put the, I don't know. I might look for other cooling solutions, that's for sure, because they really left a lot on the table on this one. All right, so let's go ahead, and you really can't do too much on the card, as long as it's a thermal insulator. I mean, an electrical insulator. So now at this point, I'm going to take and spread this out. All right, like I said, doesn't have to be perfect. It just has to be there. Okay, so now I am just double checking, but I believe I'm ready to place this on. All right, so we're going to put the back plate on. Now this is the Corsair back plate that's provided. And then they provide a bunch of screws for us to apply as well. Okay, so the backing plate is on. And now we need to put the I/O shield on. Take this, want to be flathead. So the I/O shield over here, and we need to put that on. Now I'm gonna, here's another source of beef I have to pick with Corsair. When it comes to reinforcing the I/O shield onto this board, now the I/O shield is important because the I/O shield is what's going to do all the, it reinforces the board. It reinforces this structure to the motherboard through these pins and then through this screw here. So the I/O shield's important. And there's three larger screws that normally fasten into the stock heat exchanger. In this case, they're just straight up missing. And these screws that fasten the bottom part to the board, they just want you to use a screw and a nut. So, well, there it is. So that's the back plate. The front side, I mean, it's got shine, it's got bling, but it definitely leaves a lot to be desired. Okay, so here it is. Our 2080 Ti has been Corsair water blocked. So it's a little bit smaller. It's actually not much lighter. It is a little bit smaller though. But old versus new. So I'm going to go ahead and start working down, I have to drain the water loop in this computer, and I'm going to go ahead and actually put the card into the computer and plumb it up, and then see where we can go with it. So I'll get back to you right when I get that done, because I'm going to need a couple hands for that one. Okay, so now that I finally have the computer back together, the water circuit purged of air, and everything else that goes along with putting these things, well, together, there's a few things I want to mention. A few things that I have on my mind. One is that I am greatly disappointed in Corsair. I feel like they have left, and I talked about this already, I feel like they have left a lot to be desired for their engineering. They literally just did the bare minimums of engineering to apply appropriate cooling to the card as a whole. And I say that because I say that based on the fact that the OEM card, the OEM heatsink from NVIDIA, goes to a lot more effort. There are pieces of aluminum present in order to contact individual chips to make sure they don't overheat. Now, maybe NVIDIA went over and above, but is it wrong to expect, when you pay this much money for other cooling solutions, that they go to just as much effort in order to make a good product? I don't think that's a wrong expectation, but they definitely didn't. Corsair did not go to nearly as much effort as NVIDIA did to make sure that the components on the card, all the components on the card, stayed cooled, are actively cooled. So that's a disappointment, definitely. I also learned another thing. These sys cooling pumps are utter garbage. Now, some of you might laugh at me and go, well, duh. I'm not a tech tuber, and I am not the end-all opinion when it comes to computer electronics. So for a lot of this, for me, this is a learning curve as much as anything. This pump is definitely garbage. It is not moving the amount of water that I think it should be moving, and it took a very long time to get the air out of the loop and properly fill it. In fact, I'm pretty sure there's still a giant air pocket in the radiator. Now, the radiator is grossly oversized for this application, so I'm not nearly as worried about it. We'll deal with it when we get there. So I still have the RGB Corsair solution for the CPU block to install. So I think what I'll do is make another video and try to get some resources together for that, to upgrade the CPU block itself and upgrade our pump/reservoir arrangement and try to get better water flow through the entire situation. Other than that, I think this is working out all right. Am I satisfied with Corsair's, with the effort they put into making the block? No, I am not. But it is still a good block. I can't say that it's garbage because, for one, my opinion doesn't really carry a lot of weight. Like I said, I'm not a tech tuber. This is the first water block I've ever put on there. And as a matter of fact, if we are judging the amount of effort or detail it takes to assemble the block, given that you don't have to apply any thermal paste or thermal pads, I'd say they hit the nail on the head. An amateur like myself can definitely take apart their graphics card and put this component in without having to worry that they're going to completely mess everything up. I mean, you know, relatively speaking, still pay attention to the details, but I think they did a good job on that. So this takes us a step closer to all the fun cooling experiments that we want to do on this thing. And the next step is going to be the CPU block, as well as upgrading the pump and reservoir arrangement. Oh, and another thing that I find annoying. Why do you have to have an extra piece just to run the RGB in Corsair's products? Am I the only one that thinks that's ridiculous? There's an RGB header on the motherboard. Why do I need to use Corsair's crap? I think I should be able to plug, and I'm going to look into doing that. I think I should be able to plug their RGB arrangements onto the ASUS's RGB header. But, you know, Corsair wants to sell you another product. So, love corporate America. Oh man, I'm gonna get yelled at for that remark, but whatever. It's still ridiculous. It's still ridiculous, and I'm standing by that. All right. So thank you very much, guys, for watching. I know this has been a bit of a longer video, and for anybody that's actually watching this because they want to liquid cool their graphics card and you've never done it before, hopefully this helps you out in seeing some of the obstacles that you're going to have to overcome. Don't be afraid to go on other channels, such as Jay-Z's 2 Cents is a great resource on liquid cooling stuff, as well as, you know, the usual Linus Tech Tips and Bitwit and all that, all the rest of the fun stuff. They have great resources to where you can see a more detailed, in-depth, you know, description on exactly what you need to do. They do a better job at that because, well, they're the professionals. So thank you very much for watching. I appreciate it. Hopefully you found this entertaining and somewhat helpful. I thank you very much. Keep in touch. Make sure you hit that subscribe and make sure that bell icon so that you're notified. Because, like I said, this is just the next step towards some of the fun cooling stuff that we're going to do with this. We're going to be doing some cooling arrangements with this computer that nobody has ever done before. And I mean that without doing my research. So I probably shouldn't say it in public. But I have never seen anybody do the things that we're going to do to cool this computer. So it's some sciencey stuff, and it's going to be interesting. So make sure you're subscribed and make sure you get that bell icon so you're notified when the videos come out. Again, I appreciate you for watching. It's awesome. Come back. As always, I'll see you in the next one.
Bye-bye.